Hi, everyone. How's everyone doing?
Adequate.
Adequate? I think adequate's a high bar right now.
Yes, it is.
How's the homework going?
Professor,
Uh-huh.
just curious. I turned in a test late, and the grade hasn't come in yet. You know when I can possibly expect the grade for it?
Oh, is this the multiple choice?
Yes.
I got to go back and look at it.
Thank you.
Yeah, thanks for the reminder.
Thank you.
No problem. We're still a little bit early. Sun's out today. They're starting to open up the parks. These are good signs. Oops, I don't want all that. More people coming. Of course. Put this on. Let me put. Oh, I'll type this. I added another video to the chapter 10 slides that goes over polarity. Grab another one. Everyone's so quiet.
I have a couple of questions for you, Professor, when we start.
Okay, well let me go over the announcements and then we can dive into questions. I'm just waiting I have to let people in. So I'm just okay. So I'll go ahead and get started. So for today, what I thought probably the best use of the time is to go over questions on homework and chapter 10, whatever questions you have. The homework number 9, which is on chapter 10, is due Friday. And then once you're done with that, you want to get started on the chapter 11 slides because we have an exam coming up a week from today.
All right.
Yeah. But I think I bought us some time. So, and so then get started on that chapter homework 10, which is on chapter 11. It's due after the exam on May 1st, that Friday, but you need to know this material for the exam. I put the due date after the exam so you don't have to stress about format and whatever. But so if there are things that allow you to get your full points, you have till after the exam to perfect it, but you want to make sure that you work those examples before, you want to make sure you work those examples before the exam, even if you don't have them perfect for the points on the homework. So Monday's class, spend time answering questions on homework 10 and chapter 11. And then what I thought, because I figure that's kind of fast, Wednesday is the exam. So we'll have our regular Zoom session. And I'll answer whatever questions you have about chapters 9, 10, and 11 at 9:30. And then I'll open up the exam after the Zoom session. Now, because of the way, because we are a class that started during a regular meeting time, I have to make sure that if someone needs to have the exam during our regular class time, that I allow that to happen. So please make sure you contact me if you need to if you need me to open up the exam at 9:30 in the morning. And then for you, I can do that. But I can't do it for everybody because what I don't want to be doing is answering questions while the exam is live. But I think most of you are going to benefit by using that Wednesday morning session if you want to get last minute questions answered. Does that make sense?
Yes.
Yeah. Okay. So Carla asked, will you have 24 hours again? Yes. So here's what I'm thinking. It's going to take, I think I can get this to work. My plan is to have the exam in one place. It will be entirely on Canvas. It will be multiple choice, and there'll be some written response. And it'll be there'll be 2 sections in a module on Canvas. And what you'll do is you'll open the test. It'll be in the regular format of like a pre-lab. And you will answer multiple choice, and then you'll put in the numbers for if there are numeric responses, you'll put those in or written responses, you'll type those in on the exam, but you'll have to show your work. And the way you'll do that is you'll finish the exam during the allotted time and submit it, but you're not going to be able to show your work at that point. So the next step will be for you to upload your written answers, but that will be outside the window of the time. So you'll enter your numbers in the exam, submit it, then go to the next step in the module, and that's where you'll upload your work. And that is not time. So there's no time pressure for getting that file uploaded.
Okay.
And you'll have you'll have 24 hours. I'll give you I think 2.5 hours should be more than enough. Well, 2 hours to do the exam, and then you upload the file after you submit it, probably within half an hour. And you'll have a 24-hour window to work on it, those 2.5 hours. Any questions on that?
President, rough guess, you know about how many questions are going to be on the exam?
At this point, no. I'm planning on 30 multiple choice, 10 from each chapter.
Mm-hmm.
And then, we've got electron configurations, we've got Lewis structures, we've got polarity, we've got some gas law stuff. My guess is probably 2 to 3 questions per chapter in the written response.
Okay.
But I think my experience is the more Lewis structures you have the opportunity to do, the better off you are, because if you make a mistake on one and there's only one, that's catastrophic. But if you make a mistake on one and there's 5, it's not a big deal. You know what I mean? So it's a balance between time and distributing the points over a variety of questions. I'll try to provide more guidance on what to expect. I think, it's 3 chapters. We've been working on those skills. It's pretty much what we've been doing, but I'll try to provide a list of what, and I'll look on the resource site to see if there's a sample exam for the free response, for the written response. So that's a question about the study guide. I don't have a study guide at this point, but I'll try to get something, either a sample exam or a list of skills. But essentially, if you do the problems at the end of the chapter and what's been in the homework, you'll be in a good place. Okay, so hopefully that simplifies the exam process. I just uploaded, so in the chapter 11 slides, these are gas laws, which is sort of, I actually like lecturing on the gas laws chapter because it's stuff that we don't think about on a daily basis, but we actually do experience some of these phenomenon. So I'm missing being able to lecture on that live. I put links to several Khan Academy videos. Most of you know Sal is kind of slow at Khan Academy, but he does a very good job. So I apologize for the length. Like some of them are 9 and maybe 15 minutes. I added 2 shorter videos of my own stuff, but I do recommend, he does a very good job of describing some of the concepts of what pressure is and pressure and the various gas laws. And there are sample questions on Khan Academy that are at about the right level. But the ones that I did, I just uploaded right before class. Okay, so who's got questions?
I have a question.
Uh-huh.
Do you have your textbooks? Can you?
I do. It's
Okay.
next.
I'm looking at page 292 and 293. That Bohr model.
Yeah.
Bear with me. Let me get to those pages, Professor.
Okay, 292, 93. Yeah.
I'm getting there. Okay, I'm looking at that Bohr structure on, look at that figure 9.9 that says Bohr orbits.
Yes.
The orbits are tight around the nucleus and they get wider as you get away from the nucleus.
Yes.
Then I looked over here at this figure 910 Bohr energy ladder,
Uh-huh.
and the orbits are wider at the nucleus and they get tight away from the nucleus. I was
Oh,
wondering,
so you mean the rungs on the ladder?
the rungs on the ladder.
Oh yeah, that's interesting. Don't read into that too much.
Okay, good.
I think it's because the energy is proportional to the square of the radius. Mm,
I'll go with, I'll
don't
agree
worry
with
about
you.
it.
Don't
Don't
worry
worry.
about it.
Yeah.
I saw that. I said, what is going on with this thing?
Yeah. How's the homework going so far?
Pretty good. If I if I get 93 or above, I'm sticking with it.
Uh-huh.
I'm not going to redo it.
How's the drawing of the structures going?
That that to me, it's going pretty good, but it's still kind of, I got some iffies going on in there. And one of them is, Professor, I'm looking at water. I know water is polar, correct?
Yes.
But when I did the electronegativity count, it comes up to 0.
Electronegativity count? You mean the
Yeah,
difference in
delta
electron?
En,
Huh?
that delta En,
Uh-huh.
you got oxygen has 6 electrons, and then you have 2 pairs and 4 free electrons. So 6 minus 6 is equal to 0, correct?
You mean so you're talking about the formal charge?
Yes.
That's not the same as the delta En. Formal charge you always want to be 0 as much as you can. I'm trying to
But
find my table of the electronegativities. Oh, that's chapter 10 though. We're in the wrong chapter.
So hydrogen has a complete.
and I was thinking, when I drew that hydrogen molecule, I mean that water Lewis structure, I must be missing something because I had that thing almost as being linear.
Oh no, let me show you. Um,
I had 2 free electrons above the oxygen and 2 free electrons below the oxygen.
no, so they go together.
Okay, so they're on one side of the oxygen atom, and that's going to really make it.
This structure is done.
Yeah. Okay, so do you guys see my camera now?
Yes.
Okay. So water, the Lewis structure. Hydrogen has 2 electrons, oxygen has 6, so we have a total of 8.
Right.
There's the oxygen, there's the hydrogen.
Molecular shape and show you the possible.
Is that me? Or is I hear my voice. Am I playing one of my own videos?
I hear some talking in the background. I don't know what it is.
It sounds like my video. All right, well, let me go back to here. You guys still see the screen, the whiteboard, right?
Yes.
Okay, so this is the Lewis structure, and those unbonded pairs, don't think of them on the opposite side, they're going to be together. And let me pull up, I'm trying to see what you see. I got the wrong thing up. Okay. Okay, so they're on the same side. Here's my molecular model, right?
Right.
This has a steric number of 4 because there are 4 groups. There's
Right.
1
4.
to each bond,
Right.
and then there's the two unbonded pairs. So
Yes.
that makes it tetrahedral electronic geometry. So here's a tetrahedral atom, my central atom. I'm going to take off two of the bonds to atoms and replace them with unbonded pairs. Do you see how the unbonded pairs, no matter where I put them, they're going to be next to each other, and it doesn't change the bond angle of the remaining electron groups to atoms. So this is still 109.5, 109-degree angle. And think about really these two unbonded pairs. One would be coming out of the board and one would be going back. Can you see that?
Yes.
Yeah. So the electronic geometry is tetrahedral with an angle of 109 degrees 0.5, and the molecular geometry is called bent, and the angle stays the same.
Okay.
Oops.
I'm looking at page 338, Professor.
Uh-huh.
I see the structure. The bottom one is tetrahedral and it's bent, but they draw that structure like a linear structure.
Wait, where are you?
I'm on the bottom of page 338,
338.
and they have that oxygen Lewis structure for the oxygen there.
Is
It
this
says,
the water? I think it might be on 337. And
in my book, I'm looking at that on table 10.1 on the bottom of page 338.
on the table. Yeah, that's an unfortunate drawing. So see how the Lewis structure is linear, but the molecular model
Right. You have two unbonded
here, right?
Yes.
This is unfortunate. Lewis structures are not meant to imply geometry.
Okay.
So as a Lewis structure, this is totally fine. If I asked you to do the geometry, this is what I would expect here.
That's what threw me off.
Yeah, I can understand that.
Why would the book do something like that?
Space. Okay, what other questions do we have?
This is a sort of an old question, Professor.
Uh-huh.
On the those group 7 was it group 6 elements? When we talked about that SO2 last time, there were two ways you could draw it.
SO2?
Yes. You could draw with, double bonds, or you could draw it with one double bond and one single bond. You said both of them were better. Both of them were good, but the double bond was better. And you said group 6 are the only ones that could have that type of structure.
No, what I said is third row or lower, period 3 or lower.
Oh, period 3 or lower.
This has an expanded octet, right?
Okay, yes. So
And that's because it has d orbitals. Nitrogen does not have d orbitals, but sulfur does. They're not filled, but they're there. And so that allows it to have an expanded octet.
Right.
That's why this can have 2, 4, 6, 8, 10. And we know that that's better than just having the octet, because if you calculate the formal charge on that sulfur, it's the number of valence electrons, 6, minus the number of bonds, which is 4, minus the 2 unbonded pairs. And that gives you a formal charge of 0, which means it's stable.
Yes.
Ooh. Oh, what happened to Victoria? She was in and then she was out. Let me let her back in. I understand. So Javier's got a question. I understand how to draw Lewis for a molecule with 2 elements, but I get confused when the drawing has Lewis structure with 3 elements. Can you give me, Javier, can you give me an example molecule? We could do methylene chloride. Oh, okay, H2CO, that's good. Let's do that. Okay, so this is actually formaldehyde. And I think at this point, we know that hydrogen has to be on the outside.
Right.
And we know that oxygen has to have 2 bonds. I would put carbon in the center, oxygen here, hydrogen, and hydrogen. We'll add up all the electrons. Hydrogen is going to give us 2 electrons. Carbon will give us 4. Oxygen will give us 6. So we have 12 electrons. Put a bond in between each of them that uses up 6. We have 6 electrons now. The next thing to do is to fill the outer octets, and that's oxygen. That uses up all of our electrons.
Yes.
But our issue here is that carbon doesn't have an octet yet. It only has 6 electrons. So what we'll do is we'll take those 2 and we'll put them here.
Get a double bond.
Yeah, we ran out of electrons before we got the octet of carbon filled.
Yes.
And oxygen is going to be happy with two bonds. It can be a double bond or it can be 2 single bonds to other things. And so if we look at the formal charge of that carbon, it's going to be 4 valence electrons minus the number of bonds, which is 4, minus the number of unbonded electrons, which is 0. And so the formal charge on that carbon is 0. The formal charge on oxygen is 6 valence electrons minus the number of bonds minus the number of unbonded electrons, and that is 0. Where's my real estate here? Oxygen, I gotta do it over here. Oxygen with 2 bonds and 2 unbonded pairs always has a formal charge of 0. So it could look like that, or it could look like the oxygen in water. Both of those will have a formal charge of 0. Good question. HCOOH was in the homework and that was a bit confusing. Yeah. So HCOOH. You will start to recognize groups. This is going to be a carboxylic acid. Without knowing that, how would you know how to do this? I think at this point, I would give you the framework. I would say, okay, give me the Lewis structure with that.
Well, you know, the hydrogen bonds are going to be single bonds.
Yeah, so we have, and so let's calculate. I've got a couple questions going here. So the number of electrons
Okay.
is 2 plus for the hydrogens, 12 for the oxygens, 4 for the carbon. So that is 16, 18. So I'm going to put in my bonds. 2, 4, 6, 8. I got 10 left. I know that my oxygen's going to want 2 bonds. And that carbon's going to want 4. So let's see, do I have 2, 4, 6, 8, 10, 12, 14, 16, 18. So I used all of my electrons. So I would say, how did I do this? I know carbon is going to have 4 bonds.
Right.
If the oxygen is uncharged, it's going to have 2 bonds. And hydrogen is going to have 1 bond. So would the answer still be correct if the oxygen were at the bottom? I'm not sure. Do you mean having it like, if I had it like this, that would also be fine. Does that answer your question, Javier? Oh, good. Okay. Yeah. The geometry in the Lewis structure. Oh, but you would still need to have that. The geometry in the Lewis structure is, it's okay. We don't care about the geometry when you do the Lewis structure. We care when we ask about the type of geometry and if we ask you to draw the shape. Okay, what other questions do we have?
Professor, back to that
SO2?
SO2. Yeah, can you draw the electron structure for that?
The Lewis structure or?
No, the electron configuration for that. You got the 1s and 2s and the various.
Oh, well, the electron configuration is per atom.
Oh, per atom. Okay.
Right. So the electron configuration for sulfur, if I were going to abbreviate.
So it'd be 3s2 first.
Yeah, I would abbreviate using neon because it's at the end of the previous row. So neon. And then, yeah, well, let's see. It's here. 1, 2, yeah, 3s2.
3s2,
And then it's 1, 2, 3, 4 in the P block.
in the P block, right?
3p4.
Okay. I agree with that. Okay. There's no D's in there because you're not down there to the D
Yeah, correct.
structure. Got it. Okay.
Yeah.
Thank
If I
you.
wanted to do selenium,
You'd have the D's come in play.
yeah, so selenium's here.
So it'd be
So
AR.
yeah, argon. And then I would go 4s2.
10.
Yeah,
3D,
3d10.
10. Yeah.
1, 2, 3, 4. That's all 10 columns. And then
Right.
1, 2, 3, 4, 4p4.
Right. Got it.
How's the workload been? How many hours are you guys spending on looking at this?
Hours.
Hmm?
A
A lot?
of hours. A lot of hours. What else have I got to do? I'm stuck at home.
Yeah. I think they're gonna loosen the binds a little bit, but I don't want to see us rebound. We had a bad numbers day yesterday. 100 people, 109 new cases yesterday. But I think being able to walk around on trails and in parks hopefully won't impact that too much if people keep their distance. Just be happy we're not in New York.
True.
What other questions do you guys have? Let me know what I can do to help. I did question number 92. I did a video of that and posted that. Oh, I like this one. So classify these diatomics as polar or nonpolar? So I2, is that going to be polar or nonpolar?
I2, that's going to be nonpolar.
Yeah, this is nonpolar because I have a covalent bond. This is the Lewis structure between two iodines. And so they have the same electronegativity. So the delta electronegativity is going to be 0.
Right.
Okay, what about NO?
NO. Right now, off the top of my head, I'd call it polar.
Yeah, why?
Well, you got two different elements there, and I know if I do electronegativity count on that thing,
This has an ugly Lewis
I
structure.
know it's gonna. Yeah, I know it's gonna be nonpolar.
I think no, it's polar. Let me see, there's an ugly Lewis structure. It's 5 plus 6. So here's one of the rare cases where we have, no, I can't do that. 2, 4, 6. We have an odd number of electrons. Remember, if I tell you if you add up your electrons and you get an odd number, double check. But this is actually true. So right now I have 2, 4, 6, 8, 10, 11. Yeah, that's the Lewis structure. Oxygen is more electronegative, so it's going to pull. The electron density is going to be greater around the nitrogen, around the oxygen than the nitrogen, and so there'll be a dipole. So this is polar. Anytime you have a diatomic between two of the same atom, it will be nonpolar. So N2 would be nonpolar. Okay, I got a request for question 10.10 on the homework. Let me see if I can pull it up. I've got some kind of weird mode going on in my, it wants to draw, oh, stop drawing. Okay.
Started.
I think my canvas is very slow right now, but I'm going to try to pull up the Pearson to see what it is. Okay. Nope, wrong class. Yeah, Canvas is very slow right now. I thought maybe my computer was slow on Monday because my daughter had a class Zoom at the same time, but no one's here and it's still slow. Maybe it's just because it's a busy time to be on Canvas. Okay, I'm getting there. Not there yet, but I'm getting there. Okay.
Professor, where are you getting there? Can I ask you a question?
Oh, it just told me it couldn't open my course. Hold on. Let me just click on it again and then I can. Ugh. Okay, I'm letting it open. What's the question?
On this polar and nonpolar,
Uh-huh.
you got an odd number of electrons like you showed, most likely that's going to be nonpolar. But if you have something like, say, 6 and 4 comes up to 10, that's an even number.
Oh,
If
it doesn't, polarity isn't about odd or even electrons. It's about the bonds and looking at the dipoles that come up.
okay, so if you have one with less free electron, one element with less free electrons than the other, it could
It,
still be
it's not about free
nonpolar.
electrons. It's about the difference in electronegativity when atoms share electrons.
Okay.
So HCl, do you guys still see my whiteboard?
Yes.
Okay, HCl, um, this is the Lewis structure. But the hydrogen has less electric negativity than the chlorine.
Right.
And so there's a partial, it's going to lose electrons in that bond to the chlorine. And so there's a dipole, and that makes it polar.
Okay.
Okay, chapter 10. I'm getting there. I got to the inside the course.
Well, Professor, can you give me an example of where you have two different elements and it's nonpolar?
Really the only case would be when you have a CH bond. Now, CH isn't a molecule by itself, but any CH bonds are nonpolar.
Oh, okay.
Yeah, anything else has some amount of polarity, unless if I'm giving you the electronegativities that you can look at them directly, right? So
Mhm.
I gotta find that table. Do you know what page the electron? Oh, I found it. So if let's see, phosphorus has an electronegativity of 2.1 and tellurium has an electronegativity of 2.1. So a bond between those two would be nonpolar. But
Okay.
I'd have to give you the numbers for you to be able to do that.
Understand.
Okay, let me see. 10.10. Oh, I'm pulling it up. Okay, yeah, this is a good one. So which molecule is polar? So the ones I have are SiCl4, CF4, xenon F2, and NF3. So the question is, which one of these is polar? Okay, so the Lewis structure, you really need to do the Lewis structure of each to be able to know. Let me put this up here. I don't know how to clear that. So it's, what did I say it was? It was SiCl4. That Lewis structure is this. Okay, this is going to be nonpolar
Right.
because our central atom has bonds to all of the same atom. All of them are chlorine. There is a dipole, there's polar bonds there, but all the dipoles are going to cancel because they're bonded all to the same atom, and there's no unbonded pairs on our central atom, the silicon.
Right.
CF4 is going to fall into the same category. Again, the CF bond is polar, but all the dipoles will cancel because the carbon is bonded to all of the same atoms, and there's no unbonded pairs on the carbon. So this is nonpolar. However, if you saw this, the dipoles will no longer perfectly cancel. And so this one would have some polarity. the molecule. Okay, now I also had xenon F2. So xenon has 8 electrons. Fluorine has 7, and there's 2 of them, so it's 14 plus 8. That gives us 22. Let me write down NF3 before I forget. Okay, so the Lewis structure for xenon, I'm going to put xenon in the middle. It has no electronegativity. And fluorine on the outsides. I'm going to draw my bonds. So that's minus 4 electrons. I have that many left. Minus 12, I have 6 left. Oh, that's funny that they gave you guys this, because this is a geometry you guys didn't learn. It's called trigonal bipyramidal. This one is nonpolar because these are all in a plane, and these are actually, the shape on this is linear. But you guys don't have the tools to know that. So this is not a good example for you.
Well, the free electrons are in the plane, and the Fs are coming out of, going up and down out of the
Yeah,
plane.
so if you were thinking about this, I've made a mess here. The 3 unbonded pairs are in the plane of my whiteboard,
Yes.
and 1 fluorine would be coming up and 1 fluorine would be going down.
Ooh.
And because this angle is 180 degrees, the dipoles will cancel. So this is nonpolar.
Ooh.
Okay, now, and I will tell you, I don't think that that's a fair question given the background you guys have here. But you should be able to tell that NF3 is going to be polar. So nitrogen has 5 electrons, fluorine has 7, and there's 3 of them, so that's 21, 26 electrons. N, F, F, minus 6 for the bonds. I got 20 left. That was 18, and then I have 2. So I've used all my electrons. So what is the electronic geometry of this?
Electronic geometry.
How many electron groups are there?
4.
There's 4 electron groups. That means that the electronic geometry is tetrahedral.
Yes.
And one of the legs of my tetrahedron is an unbonded pair, so the molecular geometry is called pyramidal.
Right.
And so that would be like this guy. There's the electronic geometry, but now I've put in my unbonded pair. There's dipoles between N and F. F is more electronegative. So if you think about on my molecule here, it's hard to see. It's kind of sort of flattened on the camera. My dipoles are all going to point down. And so there's a net dipole, which makes this a polar molecule. So that was a long answer to your question, but I think it was a good one because it seemed like that's what people needed more help with. And the video that I made yesterday that I posted in the slides, and it's on my playlist for chapter 10 on YouTube, goes over some similar examples. In terms of cataloging what kinds of Lewis structures to expect, nitrogen, when it's neutral, Let me do this backwards. Nitrogen will have 3 bonds and 1 lone pair in Lewis structures. Want to get rid of that line I made, but I don't know how to do it. Oh, maybe I could do clear. Yeah, got it. Okay, so Javier, did that answer your question? Good. What other questions do we have? How are the Lewis structures 1 to 10 in terms of comfort level? Are we at least a 7 or an 8?
Yeah, 7 or 8.
Okay. How about everybody else? Come on, people. Oh, I got an 8. That's good. 7's okay. Oh, good. We got a 10.
Ooh.
Brave. Do you, let's see. Let me see if there's another one we can do. Okay, how about the Lewis structure of PCl3? I'm so tempted to try to do a chat room. All right, so the Lewis for PCl3, phosphorus has 5 electrons, Cl has 7, and there are 3 of them, so that's 21 plus 5. I've got 26. Phosphorus is my least abundant element and the least electronegative, so I'm going to put it in the middle. 1, 2, whoops. Minus 6, 20 left. Oops, first I'm going to fill the outer octets. Minus 18. I have 2 electrons left, so I put them here. Notice that if I did NCl3, my Lewis structure for NCl3 would come out like this. And I'm looking for my periodic table. I moved it somewhere. But phosphorus is underneath nitrogen in the periodic table, so they're going to have similar Lewis structures and similar Lewis behaviors. The formal charge of phosphorus is 5 valence electrons minus the number of bonds minus the number of unbonded pairs, that's 0. The formal charge of the chlorines is 7 valence electrons minus the number of bonds, that's 1, minus the number of unbonded electrons, that's 0. So that's our Lewis structure. So what do you guys, what other kinds of examples do you want to see? Oh, I don't know what I do with my periodic table. Oh, here it is. Victoria, you usually have questions. Ooh, somebody said a dog. I think what we miss here is in class, I usually get a chance to have you guys try something, which helps. And here it's harder to do that. I might start trying to do, I can actually do breakout groups during the Zoom session. One other sort of unique trait is if you look at this column here, column group 3A, boron and aluminum, those are unique in that they do not, they don't require an octet. They're happy with 6 electrons. And so that is group 3A. So these are Lewis structures for those for boron and aluminum. Okay, so a lot of us have lab at 11:30. I looked through it. It seems pretty self-explanatory. I'll log into Zoom. You guys are welcome to get started on the lab if you want at that time. And I'll be close to my computer and can answer questions. Do you guys have any other questions for lecture stuff? Okay, well, get it. I think maybe you guys will, let's see. No, you have homework due on Friday. Email me questions if you have specific questions about the homework between now and then when it's due. If there's no more questions, I'm gonna end the session.
So we'll have lab and we'll come online again at 11:30, correct?
Yeah.
Okay.
I looked it over. There was one thing I was gonna talk about, but the second video did a pretty good job of showing it. But yeah, I'll come online then. I'm not gonna have a whole lot to say, I don't think, though. Did you have questions about, I know the pre-lab, I don't know why it was showing you your scores. I like it, but it doesn't, when it doesn't show, because, yeah. Oh, good. Yeah, you guys gotta keep up with stuff. Thanks, Victoria. Yeah, I liked it. I haven't figured out how to get how to get those quizzes to handle numbers properly that give you flexibility. Hopefully I figure that out for the exam, but and I don't want it to show you scored. All right, so I'll see you guys at 11:30. I think I'm gonna start some sourdough bread between now and then, making it.
Thank you, Professor.
Oh, you're
Thank
welcome.
you. Bye.
Bye, guys.
Bye, Professor. Thank you.
You're welcome. I hope it's helpful. Okay.